In this video, we will review ratios, rates, and unit rates, and what makes ratios proportional. The first question reads, is the following a unit rate? If not, find the unit rate. So I'm looking at the fraction. This is a complex fraction. I notice that I have 1/2 as the denominator. Well, to be a unit rate, I need a whole, or one whole rather, 1 as my denominator. So the first part of this question is no, it is not a unit rate. Okay. And how do I now determine or find the unit rate? Well, I need to go from 1/2 to 1. So I'm going to multiply 1/2 times the multiplicative inverse, right? What is the inverse or multiplicative inverse of 1/2? That would be 2. And I would need to do the same on the top. So 1/4 times 2 is 2/4 or 1/2. And 2 times 2 would give me 4. So the unit rate in this situation would be 4½ hours, or rather miles, for 1 hour. Okay, so now we have Miss Angowski. She ran a 5K, which is 3.2 miles. I'm going to put a box around that 3.2 miles in 24 minutes. How long will it take her to run 1 mile? Now, when we just talked about this in class, many of us were confused by the 5K. The 5K is a name of the race, and that is a measurement in kilometers. However, I am concerned about how much she runs in miles. So I'm going to use the 3.2 miles. So we have our miles. Actually, I'm going to change that. I want the minutes and miles rather on the bottom, because I want my 1 as my denominator. It just helps me figure that out. So my minutes would be 24 and my miles would be 3.2. And I want to go to 1 mile. That's 3.2. So how would I go from 3.2 to 1? I would need to divide by itself. I'm dividing by 3.2. And if I divide by 3.2 on the bottom of my fraction, I need to divide by 3.2 on the top as well. So put that in your calculator. 24 divided by 3.2 will give me 7.5 or 7½ minutes in 1 mile. All right, so now we have a question that I know we all have come to love, and that is, which graph is proportional and why? Well, first of all, let's look at this graph. Now, one of the 4 properties of a proportional relationship is that it forms a straight line that begins at the origin, right? And I can look at this right away and say, you know what? This is not a straight line. It does begin at the origin, but it does not form a straight line. Not to say that straight. So I'm going to cross that out. So now let's look at this one. Is this one proportional? We can't just assume it is. It looks like it does form a straight line. It appears to be straight. It is starting at the origin. And now what is our unit rate here? So I have let's see, 92 over 2, and I'm going to pick another one here, 368 over 8. So I'm just going to use these to determine if indeed it is proportional, to see if I have the same unit rate here. And sorry if I'm writing over that text if you can't really clearly see. So we have 92. That gives me 46. And will I get 46 over here? So now, not only does it form a straight line, or it appears to be, and it is indeed a straight line that goes to the origin, we know that it is increasing by a constant proportionality of 46 over 1 each time. We have Miss Coley. She's making her famous Nutella Cocoa Rice Krispie Treats. It says she needs 1/3 cup of Nutella, 10 ounces of mini marshmallows, 6 cups of Cocoa Crispy cereal, and 16 bar to make 16 bars. Okay, that's a lot of information. We got the entire recipe here. However, she has, and I'm reading this a little crazy, she has 1 cup of Nutella. So we'll put a box around that. And she wants to use it all. How many bars can she make? So if I go back in this text, do I care based on this problem about the marshmallows? No, I'm going to cross it out. Do I care about the 6 cups of Cocoa Crispy cereal? Not at all. I'm going to cross that out as well. So the only thing I really am concerned about is the amount of Nutella she has, which is what she needs and has, and how many bars that makes. So I am going to now set up my double number line, or my equivalent ratios. I have Nutella and I have bars. It says she needs 3, or rather 1/3 cup Nutella to make 16 bars. And again, if you need to go back, just make sure you circle that so you know what she actually needs with the recipe. She has 1 whole cup, right? And many of you are saying, oh, I see exactly what I need to do. So I need to figure out this missing part here. How many bars can she make? Well, we're going to multiply by the multiplicative inverse, or the reciprocal, right? The reciprocal of 1/3 is 3, and I'm going to do the same here on the bottom. And so 16 times 3 would give us a total of 48 bars. All right, so let's see. Determine the value of a point A on the graph. What does it represent in the context of this problem? All right, so we're going to determine the value of this point. So what we need to do first is figure out what is the independent and dependent variable. We have the number of hours on the x-axis and the total cost on our y-axis. And we talked about this in class, that the number of hours determine how much the total cost of this electricity will be. So what does it mean? It means that let's go, just to make sure this is clear to us. In 6 hours, the cost for electricity will be $60. And we could also then figure out what the unit rate would be based on that. So we have $60 for 6 hours. I want 1 hour. Well, I would divide that by 6, divide this by 6. I would get $10. And if I look on my graph, it looks like, yep, slightly between the 0 and 20. And at that 1, we could find our unit rate. Would be, in this situation, 1/10. Alrighty, we don't have much time left in this video, so I think, should we do Mr. Branch, or should we look at, let's look at Nay here. And if we have time, I'll go back to Branch. So Nay is celebrating her birthday and wants to buy cupcakes for either Georgetown Cupcake or Baked and Wired. At Georgetown, it costs $26 for 8 cupcakes. And in fact, let me go back and make sure I'm labeling this. So we have dollars and over cupcakes. And I have 26 over 8. And if you want to go through that text and say, you know what, I want to circle this, I'm going to use my cube strategy, go ahead back and do that. And this is Georgetown. At Baked and Wired, we have 23 cupcakes for, or $23 for 6 cupcakes. Okay, where should she go if she wants to spend the least amount of money? So I want to figure out what my unit rate is here first, right? Because it looks like here she's getting a better deal. For 8 cupcakes, she spends $26. For 6 cupcakes, or she spends $23. But let's figure out the unit rate to actually determine if that is the case. So we have our 26 divided by 8. And for one cake, it is $3.25 for one cupcake. All right. Again, I could divide 26 by 8 this way, or I can see it is moving across and divided by 8 going horizontally. And so the same is true here, 23 divided by 6. And I, or she, would pay $3 and looks like around, I'm gonna just round that to 83 cents. So for 23, she gets 6. Or one cupcake costs $3.83. So let's go ahead and put a box around this because it determines our unit rate. So it's clear, even though she might spend a little bit more up front, or if she even wants 8, she would get a better deal at Georgetown than she would at Baked and Wired. All right, hopefully this video was helpful to you. I will see you in class.